Hi, Algebra 1. This is going to be for sections 5.11 or 5.11 all the way to 5.16. So if you have any questions, after the video, make sure you talk to your teacher about it. All right, so this talks about, it says we've graphed linear equations in one variable on a number line, okay? Now we're going to graph linear inequality. So an inequality is greater than, less than. So we did that on a number line, and if you recall, we shaded one way or the other. Since two variables are involved, the solution set will look like well, in this case, it'll look like a line, okay? To graph the inequality in two variables, graph the linear function as it was an equation, then blank the solution set. So test the solution set, I think is what we're supposed to put here. If I use different words than your teacher, I'm sorry. Shading, to check to see if the ordered pair is a solution to the linear equation, or linear inequality. Substitute the values for x and y and to see if the inequality is true or false. Then shade the half of the plane that includes the solutions to the inequality. Okay. So let's just move up this, not worry about too many more of these. So let's take a look at problems 1 through 4 on the examples. So first thing we have to recognize is we have an inequality, so we have 6x plus 8y is greater than 20. I have to realize this is an x value and this is a y value. We're going to replace the x and y value in our equation up above here and here. So I'm going to get 6 times negative 1 plus 8 times 3 is greater than 20. So we're seeing if this is a true statement or not. Okay, and this is just telling us if it does work. So 6 times negative 1 is negative 6 plus 24, because 8 times 3, is that greater than 20? Negative 6 plus that is going to give me 18. Is 18 greater than 20? This is false. So this is not a solution. All right, problem number 2, we're going to take a look. This is an x, this is a y value. We're going to replace our x and y value. So 3 times negative 2 minus 4 times half is less than 14. That's negative 6. Half of negative 4 is negative 2. Is negative 8 less than 14? Sure is. This is true. This is a solution. All right, number 3, we're going to plug the x and y value in to see if this makes a true statement. So I'm going to get negative 10 for my y value. It's less than or equal to 3 times negative 2 minus 4. Negative 10 is less than or equal to negative 6 minus 4. Is negative 10 less than or equal to negative 10? It is, so this is a solution. Okay? If you didn't have the equal sign, it wouldn't have been, but it worked out nicely. Again, x and y value, plug it in. Negative 2 greater than half x minus 7. So negative 2 is negative 2 greater than half of 10 is 5. Is negative 2 greater than negative 2? It isn't. It's equal to, but I don't have an equal sign, so this is not a solution. Okay? All right, now we're going to take a look at graphing these. So let's take a look at 5 and 6. So these are going to graph just like normal lines, but one thing that we have to know is if you have this or if you have this, your line's going to be solid. If you have this or this, the line's going to be dotted. Okay, so let's keep that in mind when we graph. The first one is set up in slope-intercept form. So negative 5 is down here. I have a slope of 2 over 1, so from here I'm going to go up 2, right 1. It has the equal sign, so it's going to be a solid line. Now we have to figure out a test point. Okay? If 0, 0 works, 0, 0 is definitely above this line. So if 0, 0 works, if it's true, I'm going to shade above that line. If it doesn't work, I'm going to shade the other side of the line. So I'm going to plug 0 and 0 in there. So 0 is greater than 0 minus 5. is 0 further to the right on the number line than -5? This is true. So if that's true, that means I'm going to shade all up in here. So up here is our solution. Okay, let's try the same thing with number 6. +2 is right there. I have a slope of 1/3, so up 1, right 3. I don't have the equal sign, so this has to be a dotted line. Does 0, 0 fall under the line? It's away from it. It doesn't fall right on it, so I like 0, 0 as the point to plug in. So 0 is less than 1/3 times 0 plus 2. 1/3 times 0 is 0. 0 plus 2 is 2. So is 0 less than 2? That's true. So I'm going to shade this region down here for where our solution lives. It, goes right up to the line. And you don't have to make it a perfect shade. Let's take a look at number 7 or number 8. This is our cover method. So that's an x value, so 6 times what gives me 12? That's 2, so 0, 2. That's a y value, so 2 times what gives me 12? That would be 6. It doesn't have the equal sign underneath it, so this has to be a dotted line. 0, 0 is down here. It's below it, so let's see if that works. I plug 0 in there and 0 in there. 2 times 0 is 0. 6 times 0 is 0. 0 greater than 12? No, it's false. So I'm going to shade the opposite side. I'm going to shade the opposite side of this. So notice my test point is below it. My shaded region is opposite of it. Okay, again we're going to use 0, blank, blank, 0. So that's an x value, so -3 times what number is +15? That's -5. So that's 0, -5, which is down here. That's a y value, so 5 times what gives me 15? That would be 3. It has the equal sign underneath it, so we're going to make it a solid line. Take a look where 0, 0 is. The only time we won't use 0, 0 is if our line goes right through it. So we're going to plug 0, 0 into here. So again, if I plug 0 there, 0 is there. 5 times 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. Is 0 less than or equal to 15? That's true. Okay? So that means I'm going to shade up here. I'm shading the side because it's true. The side that is true has the 0, 0 on it. And that's all we have to do. Let's take a look at 9 and 10. It looks like we have a special case coming up. All right, so problem number 9. Our point is going to be opposite of the -5, so it's +5, opposite of the -4, which is +4. So 5, 4 is up here. We have a slope of 1/3, so I'm going to go up 1, right 3. It doesn't have the equal sign, so it's got to be dotted. 0, 0 is still below that, so we can use 0, 0 as our test point. Let's plug 0 in here, plug 0 in here. So 0 minus 4 is -4, is less than 0 minus 5 is -5. -5 times 1/3 is -5/3. Okay, so is -4 less than -5/3? Yeah, it's further to the left on the number line, so this is true. So I'm going to shade the region down here where the 0, 0 lives. On this special case, remember y equals a number is a horizontal line, so I'm going to go up to 2, put a dot. We have the equal sign, so I'm going to make it a solid line this way and this way. And then I can't really use 0, 0 because I don't have both an x and y value, but I can still think about where that point is. So if I use 0, 0, I'm only using this 0 to say it. And is 0 greater than or equal to 2? Nope, that's false. So I'm going to shade up above the line. All right, number 11, number 12. Number 11, my point is going to be opposite of that, so I'm going to get 2 opposite of that, which is -3. So 2, -3 is down here. I have a slope of -1, which is -1/1, so I'm going to go down 1, right 1. I have an equal sign, so I'm going to just take it like this. I see where 0, 0 is not touching it. It's kind of close to my line, but I'm pretty confident that 0, 0 is there. So if I plug 0 in there, 0 in there, 0 plus 3 is 3, less than or equal to 0 minus 2 is -2. -2 times -2 is +2, is 3 less than 2. That's false, so I'm going to shade the side opposite over here. And that's it. And then here's another special case. If y equals a number was horizontal and x equals a number is vertical, and this is going to be a dotted line, and it's dotted because I don't have the equal sign. And again, I'm going to try and use 0, 0. I only have to use this 0. Is 0 less than 4? Yeah, that's true. So I'm going to shade the side that has the 0, 0 on it. Okay, we're going to go over your homework that would be assigned to you. If you just copy this down, that means you don't know it, and you're just copying off of us. To describe the error, maybe I'll just go over the even answers for you, so it's not all there. So we'll just do the evens. I don't know what your teacher is going to assign you. All right, on the first one, it says describe the error. So let's see, did the cover method work? So if I covered up the y, my x is 4. Okay, those both look good. It's dotted, I like that. Plug 0, 0 in. 0 less than 8, that's true. Ask your teacher about that one. I know I said I was going to do the evens. I'm going to change to the odds now. All right, so that's x, y. I don't know if there's an error on that one. X, y, so I'm going to plug that in. So I'm going to get 1 minus -3. -5 times -3 is +15. Is 16 greater than 12? This is true, so yes, that's a solution. Number 5, I'm going to plug 1/3 in, so I'm going to get 6 times 1/3. 2 times -5. Is that less than -8? So 1/3 of 6 is 2 minus 10. So that's -8. Is -8 less than or equal to -8? Yes, so this is a solution. If it didn't have the equal sign, it wouldn't be. This one, x and y value, let's plug them in. So I'm going to get -2 minus 4 is less than 3/4 of -8. So that's -6. Is -6 less than 3 times 8 is 24, so that's -24, so that's -6. Is 6 less than -6? No, that's not a solution. Okay. Let's take a look at this. It's one of our special cases, so I'm going to go here to 1, and it's going to be a solid line coming straight down. 0 is to the right of that. So is 0 greater than -1? That's true, so I'm going to shade over here, and that works out nicely. Number 11, I have -5, which is down here. I'm going to go down 3, right 4, and it's going to be dotted. Plug 0, 0 in, so I get 0 is less than 3/4 times 0 is 0. 0 is greater than 5. That's true. So I'm going to shade where the 0, 0 is, so up here. On this one, I have -2. I'm going to go up 4, right 3. It's going to be dotted. 0, 0 is above it, right there. So I get 0 less than 4/3 times 0 is 0. 0 minus 2 is 0 less than 2. That's false. So I'm going to shade down here. Get my point. So I'm going to get 5 and 3. So 5 and 3. Slope up 2, right 1. It's going to be a solid line. 0, 0 is here. So 0 minus 3 is -3. 0 minus 5 is -5 times -2 is -10. Is -3 less than -10? That's false. So I'm going to shade over here. And that takes care of 5.11. And perhaps your teacher has you doing all of them, so double check with them. All right, let's take a look at 5.12, and it's really just working on the same stuff. So this is just a worksheet in class. I will do the odds. Your teacher might give you all of them, but at least you have the odds to give you a chance to look at it. So this is an inequality, an old school inequality we've done. So I'm going to add 4 to both sides, divide by 3. So I got 0 here, I got 4 here. It's an open dot shading left because I want less than it. So that was what we originally had done. So use the graph pictured. And and we want to see which points work. So does 3, -2 work? No, it's right on the dotted line. 5, 0, 5, that's right up there. Yes. Let's go to 7, 4, 2. So 4 up 2, it's right on there. So that's a no as well. And then we want to take a look and see which ones work for us. So that's x and y. Plug them in. So we're going to get -3 is less than -3/4 plus 1. So that's going to give me, this is true. So yes, this is a solution. On this one, I'm going to take my x and y values, plug it in. So 3 times 3 plus 2 times 4. So is 17 greater than or equal to 8? And the answer is yes. So true, this is a solution. Then come over to number 13, cover method, 0, blank, blank, 0. So cover up the x, that's going to give me -10 right there. So 0, -10's down here. Cover up the y, so that's going to give me 4. So I get 4, 0 right there. This is a dotted line. Check to see if 0, 0 works. Plug 0 in there, 0 there. Is 0 bigger than 20? That's false. So I'm going to shade the opposite side because 0, 0 is right there. Number 15, another cover method one, 0, blank, blank, 0. So I'm going to cover up the x, so -2 times what gives me -6, and that's going to be 3, so 0, 3 is up here. This is a y value, so I'm going to just get 6. This is dotted. Let's plug 0, 0 in. Is 0 less than -6? No, that's false. So you're going to shade opposite, so we're going to shade up here. Here's one of our special cases, so it's going to be a vertical line right down that. Okay? Oh, it should have been dotted. Sorry about that. Okay? So we can't use 0, 0 because it's right on the line, so let's pick 10. Okay? Is 10 greater than 0? That's true. So shade over here. In this one, I have a y-intercept of 9, down 3, right 1, solid line, plug 0, 0 in. So 0 is less than or equal to -3 times 0 is 0. 0 plus 9 is 9. Is 0 less than 9? That's true. 0, 0 is here, so we're going to shade this region down here. That should help you on that worksheet. All right, now we're looking at our review. So I will hit upon the odds on this one. Let's zoom it in. I know we hadn't zoomed in before, but we should be all right. All right, so we want to see if this works. That's an x value and y value. So is 5 minus 4 greater than 2? Is 1 greater than 2? That's false. Let's do number 3. Plug 2 and 2 in for that. So I'm going to get 10 plus 2 is less than or equal to 12. Is 12 less than or equal to 12? That's true, so yes it is. Number 5 is 1, 0 in our shaded zone. No. 0, 0. Well, 0, 0 is going to work because it's solid. If that was a dotted line, it wouldn't work, but it works because it's equal. And then is 2, -4 work? Yeah, that's down there, it's right on the line, so yes, that also works. So just the odds we're looking at on that. All right, so use the cover method, 0, blank, blank, 0. So -2 times what gives me that is -10, so 0, -10 is down here. That's a y value. 5 times what gives me 20, and that'd be 4. No equal sign, so dotted. 0, 0 is right there. So 5 times 0, 2 times 0, is 0 greater than 20? The answer is no, that's false. So I'm going to shade down here. Number 13, our y-intercept is at 4. We have a slope of -2/3, so down 2, right 3. It's going to be a dotted line. Look where 0, 0 is, right there. Plug 0 in there, plug 0 in there. That becomes 0 then. Is 0 greater than 4? That's false. So I'm going to shade up here. number 15. Name 2 points that are solutions on the graph and 2 points that are not. Well, okay. So you have to pick points. So my answers aren't the only answers. 0, 0 is a solution. And I don't know, let's go with 2, 2. That's a solution. Not a solution. This is not a solution. So 4, negative 3. And I don't know, maybe this one, 1, negative 3. There's a whole lot of other solutions that could work, or not solutions that could work. So just be careful when you're working that. Double check with your teacher if you have questions. For number 17, we want to find the x-intercepts. So 0, blank, blank, 0. So this is the y-intercept, this is the x-intercept. So 3 times what gives me 6? Y-intercept's that. That's the y value. 3 times what gives me 6? Or 2 times 3. That's your x-intercept. Number 19, do the same thing. 0, blank, blank, 0. And they kind of have a fraction on this one, but I bet you we can figure it out. Okay, so this is going to be our y-intercept. This is our x-intercept. Half times 0 is 0. That's gone. So y equals negative 8. Oh, that's easy. And then I'm going to cover up here. I get half equals negative 8. Half of what number gives me negative 8? That'd be negative 16. We want to find the y-intercept. Well, that's my y-intercept. What's my slope? Well, what's the number in front of x if there's nothing there? Yeah, it's 1, or you could have it as 1 over 1, your choice. Let's see. Let's do some absolute values. This is 514 notes. So let's expand upon this top thing. All right, so absolute value is the distance away from 0. We've already talked about this. So absolute value of negative 5 is 5. Absolute value of 3 is 3. Absolute value of negative 1 is 1. So if I plug x in, absolute value of negative 8 is 8. Absolute value of negative 6 is 6. Absolute value is 4, 2, 0, 2, 4, 6, 8. You'll see that they kind of repeat, which is what you want. If we had graphed this, you'd have 0, 0. You'd have 2, 2, negative 2, 2, 4, 4, negative 4, 4, 6, 8, negative 6, 8. Look at that V it makes. So an absolute value graph looks like a big V, okay? So let's take a look at these and see how we do. All right, so I can go and try and plug things in. Now, if anything is ever grouped, so this is grouped by absolute values, it means it's going to shift. Remember, if I had y equals x, absolute value of x, 0, 0 was like where it turned. But because this is a negative, I'm going to go to the right. So it's going to go right there. I don't have anything out in front, so it's going to look like this. So notice it shifted 2 to the right, even though it was a subtraction. If it's subtraction inside, okay, it's going to do opposite. Like number 2 is going to go opposite of what is inside. So on this one, I'm going to go left 4, and it's just going to look like this. So it shifted left 4. But for 3 and 4, I don't have the number inside. So this, if I have a number outside, it's going to start down here at 5 and do this. And this one is going to go up 3 and do this. So if it's outside the number, it does the same direction you would think. If it was a negative outside the absolute value, it goes down. If it's a positive, it moves up. So that's kind of goofy. It's weird to think about. So we'll keep that in mind. We'll definitely be working it. The blank of an absolute value function is the highest or lowest point. I don't know, we could call it the vertex. Okay, so, but I don't know if that's necessarily important for us to know. All right, so yeah, we're going to talk about the vertex here, so vertex goes on a blank. All right, so this is our general equation. A can be any number. X is going to stay as an X. H is going to be where? So if H says H blank, the vertex from 0, 0. Okay, so H moves right if negative, left if positive. K goes positive or up if it's positive. If it's negative, it moves down. I'm not sure what these blanks all are. Vertex of the function is denoted as h comma k. So again, it's the opposite value and then the same value outside. All right, so if we want to do the transformation, so it's going to be our vertex is at 2 and up 4. So this one went, it's positive 2 because it's opposite. So it went right 2, up 4. Okay, this one is going to go left 1, down 3. This one is just going to go to the right, or to the left 5. Do the opposite value. And there's nothing out here, so you can have a +0 out there. Make sure you talk to your teacher if you have questions about this. All right, so let's take a look at, can I squeeze all those on there? I can. All right. All right, my vertex is going to be at -7, -4. So -7, -4 is down here. And then it's going to look kind of like this, up 1, right 1. So the domain, it goes forever left, right. Our domain is negative to positive infinity. Our range starts here. So it goes from -4 and it opens up to go to infinity. For number 9, the vertex is going to be at 5, 1, which is here. And then our parabola, or our absolute value, looks like that. Our domain will go from negative to positive infinity because it goes forever this way and that way, left and right. Our range is going to go from 1 to infinity. And notice I use the square bracket because that is a point. And that's how we're going to do it. Number 10, our vertex is going to be at 4, -3. So up 1, right 1. Our domain will be negative to positive infinity. Our range is going to go from that, so it's going to be -3 to infinity. Then our vertex on this is not going to go right left, so it's going to be 0, 5. Remember, when you add outside, it goes up. Our domain is going to go from negative to positive infinity. Our range is going to go from that y value, which is 5, goes up to infinity. All right, I will run through the odds on this. So the vertex here is 0, 0, right there. So we're going to go this and this. Okay, there's no transformation on it. Number 3, my vertex is going to be 0, 2 because it's outside. So it looks like this and this. Transformation's up 2. Number 5, it's going to go right 9. Transformations, right 9. Number 7, vertex is at -5, -3. Transformations, left 5, down 3. Number 9, our vertex is at -8, 3. looks like that. Domain, negative to positive infinity. Range, the y value, 3 to infinity. Number 11, vertex is at 0, 4. Our domain, negative to positive infinity. Our range from 4 to infinity. Our vertex here is going to be 5, 5. Domain, negative to positive infinity. Range, 5 to infinity. Our vertex here is going to be negative 4, negative 4. So negative 4 down here. Open it up. And so if we compared this to the graph of x plus 4, this would have went down 4. Okay? You might have all the problems to do, so make sure you ask your teacher if you missed something. All right. Graph linear function, so there's a worksheet for you, so you would, let's go over the odds for you, but I'll fill out the graph. So this is 8, 6, 4, 2, 0, 2, 4, 6, 8. So it's basically doing this. That hasn't transformed. All right, so if I have a 2 out front, that's going to change a little bit. Okay, that's going to change how fast it grows in the y direction. Okay, so I'm still going to go to 0, 0, but I'm not going to go up 1, right 1. I'm going to go up 2, right 1, left 2, up 1. So this makes it a little bit so it's steeper. Okay, it still opens up, but it's steeper. If I do a 3, so I'm still going to be at 0, 0, up 1, right 3, left 1, up 3. So this is real steep. This one is a negative, so it actually opens upside down. Okay? The negative out front flips it upside down. The negative 5 out front, I'm still going to have the 0, 0. I'm going to go right 1 down 5, left 1 down 5. So this one's like a really tight one. So just keep an eye on that. So how does a multiplying a number outside the absolute value affect the vertex? It makes it steeper, or it flips it upside down. How does multiplying a number outside the absolute value affect the slope? It changes the slope. It either makes it real steep or not steep. And then how much does multiplying a negative number outside affect the graph? It flips it upside down. Okay, keywords. Generally, an absolute value function is expressed in the form of what they have up there. A affects the slope. Okay, if it's negative, it will flip over the x-axis. So rather than opening up like this, it opens down like that. All right, so number 8, vertex is at 0, 0. I'm going to go up 1, right 4, or up 4, right 1. So the slope is going to be 4 over 1. Does it reflect over the x-axis? No. Domain, negative to positive infinity. Range, 0 to infinity. Number 9, the vertex is going to be 0, 4. We're going to worry about that later. So 0, 4 is like this. Opens upside down, so it's right 1, down 1. Our slope is negative 1. Does it reflect over the x-axis? Yes, it flips upside down. Our domain is still negative to positive infinity. Our range, though, watch this. It's going to go from negative infinity up to 4. So it comes from the bottom to the top. That's what we're doing. Number 10, our vertex is going to be 0, negative 8, which is down here. And it's going to go up 1, right 5. So this is pretty darn steep one. Our slope is going to be 5. Does it reflect over the x-axis? No. Domain, negative to positive infinity. Range is going to go from negative 8 to infinity. Oops, negative 8 to infinity. Number 11, it should have an x on it, we didn't put that, is going to be at 2, 0, so it shifts to it right. It flips it upside down, right 1 down 2, left 1 down 2. Flips it upside down, slope is negative 2. Flip over the x-axis, yes it does. Domain, negative to positive infinity. Range, negative infinity up to 2, square bracket. Write an equation for the desired. Goes up 4, left 5. Okay, so y equals absolute value left 5, so that'll be a plus 5 because it's opposite. Up 4, that's a plus 4. Translation down 1 unit with a slope of 3. All right, so this one's going to be y equals 3 absolute value of x minus 1. And that just moves it down. All right, take a look at worksheet 515. All right, describe the transformations. So slope is now 2, up 6, okay, because it's 6. We'll do number 3. This flips, makes it open down. Number 5, translation 2 units left, and reflection over the x-axis, so I have a negative. And it goes left, so that's going to be x plus 2. That's all we have to do. Number 5, translation 3 units up, reflection over the x-axis. So it's going to be a negative reflection, and it goes up. So we're just going to go plus 3. Then number 9, describe the error. So we have 0, 2, that looks good. 3, oh, it should have went upside down. Should have went this way, because that negative, that made a difference. Number 11, so the vertex is going to be at 0, 6. It's up here. It's going to go down 1, right 1. Slope is negative 1. Reflect over the x-axis. Yes. Domain, negative to positive infinity. Range, negative infinity to 6, square bracket. Number 13, our vertex is at 0, 10. Up here. It has a slope of negative 4, so I'm going to go down 4, right 1, left 1, so it's going to be pretty steep. Reflect over the x-axis, yes. Domain, negative to positive infinity. Range, negative infinity to 10. Number 15, our vertex is going to be 3, 0. Slope is 4, so 3, 0 is right there, so I'm going to go up 1, right 4, or up 4, right 1, so it's pretty skinny. Reflect over the x-axis, no. Domain, negative to positive infinity. Range goes from 0, square bracket, up to infinity. And then, oh my gosh, we kind of got goofed up on numbering, but figure it out with your teacher, we'll make it work. Cool. And this is our last worksheet that's going to go. I'll work over the odds for you. Okay, so slope is going to be 2 here, and then up 6. This one, it's just going to flip it upside down, because you just have a negative. Number 5, we have a slope of 3, reflect over the x-axis, so that's going to be negative 3, absolute value of x. The negative flips it over, and the 3 is your slope. Number 7, we're going to get a vertex of negative 2, negative 6. Down here, up 1 over 1. Slope is 1 because there's a 1 out front. Reflect over the x-axis. No. Domain, negative to positive infinity. Range goes from negative 6 to infinity. Number 9, our vertex is going to be 0, negative 5. Slope is going to be up 2, right 1. So it's going to be kind of skinnier. Slope is 2. Reflect over the x-axis. No. Domain, negative to positive infinity. Have you noticed the domains are the exact same? So range is going to go from negative 5 to infinity. Number 11, our vertex is going to be 0, negative 2. Our slope is 1, so up 1, right 1, up 1, left 1. Reflect over, no. Domain, negative to positive infinity. Range, negative 2 to infinity. 13, our vertex is going to be negative 7, 3. So negative 7, 3 is here. It's going to open down because the negative out front. Slope is negative 1. Reflect over the x-axis, yes. Domain, negative to positive infinity. range negative infinity up to 3. Our vertex on this one is going to be 3 comma 0. Our slope is going to go up 3, right 1, left 3, up 1, so it's pretty steep. Slope is 3. Reflect over the x-axis, no. Domain negative to positive infinity. Range is going to go from 0 to infinity. Number 17, our vertex is 1, 3. Our slope is 3, so it's going to go up 3, right 1, left, like this. Reflect over the x-axis, no. Domain negative to positive infinity. Those are infinities. My finger's not working. And then the range is going to go from 3 to infinity. And you're preparing for a test. So have a great day. Talk to your teacher if you need any extra help. Take care of one another.